All right, so here we are. So 5.6 is all word problems. There's going to be, if I'm remembering right, let me check my notes. I think there's 3 kinds of word problems we're going to cover. It's going to be, is it working problems? Yeah. It's, we're going to cover work problems. Is that what this is off the bat? Yeah, here we go. So here we go right away with a work problem. Sue, an experienced shipping clerk, can fill a certain order in 2 hours. Tom needs 5 hours to do the same job. Working together, how long? Excuse me. Must have a cold today. All right, so working together, how long to do the same job? Sure. Okay, so here we go. So 2 hours and 5 hours. So how do we do that? How long is it going to take them together? What do you guys think? Before I just give you formulas and we crank it out, I always kind of enjoy, maybe that sounds strange, kind of just thinking about, what do you think the answer is?
It's going to be somewhere in the middle.
Somewhere in the middle. That's not a bad thought. Yeah, what do you think about that? Seem reasonable? Right? You guys get the plan, right? One person can do whatever this job is in 2 hours. The other person can do it in 5 hours. How about if they work together? Everybody getting the question, right? One person alone can do it in 2 hours. The other person alone can do it in 5 hours. They're new, so it takes them a lot longer. What if they work together? So, what do you think? You just had to guess. Like if you had multiple choice, if you had a multiple choice answer, and somebody said, "All right, here we go. Here's multiple choice. We'll start from like really low, like 1.5 to 2.5 to 3.5 to 4.5 to 5.5. You know which?" And I don't know that any of those is really the answer. I don't think any of them is exactly the answer. But which one would you guess at? Guess at like 3.5? It was 2.5? Is that what you guys are saying?
I would say in between 2.5 and 3.5.
Somewhere in between 2.5, 3.5? Does that seem reasonable? Let's just be reasonable first before we get into all these formulas and stuff. Does that seem reasonable?
Well, yeah, because the 5-hour guy is going to slow down the 2-hour guy.
5-hour guy is going to slow down the 2-hour guy. That's certainly true, huh? What's that? It's a girl. Oh, guy. Okay, that's important. Whatever it is. That I keep saying it. Let me say it one more time. Does that seem unreasonable to anybody? Seems unreasonable to me. Yeah.
Yes, it should actually be faster than the speed of the faster person.
There we go. Why?
You're adding the speed of something to that person, so that should be.
Well said. Is everybody listening to his words? He's speaking good truth. If whoever can do it in 2 hours alone, no help at all, and somebody else comes and helps, it better not be longer than 2 hours or they're not much help. Right? It's not between them. Right? That just ain't logical. Right? We good? That makes sense? It's got to be lower than 2 hours. Right? Because that person can do it alone in 2 hours. If that other person comes and it takes longer, they're not much help. Are they? They're a hindrance. I don't know if my wife feels that way sometimes when I help in the kitchen. I think she does. So they're slowing things down, right? So that makes sense reasonably. The answer's got to be lower than the 2, because that person can do it alone in 2. What good's the other person helping if they can't get it below 2? So the real answer has got to be below 2. What could we do to figure it out? How could we actually? They're working together. How do you add them together? Yes, you're remembering formulas. I don't want to just remember formulas, though. I mean, you're right. Good memory. Good job. But yeah. So let me. You know when I read these, guys and gals, think with me. I always used to read like, okay, they're working together. They're combining their efforts, right? So I would think, okay, 2 hours for one person, 5 hours for the other, and they work together 7 hours. Easy question. Add them up. But then I knew that was crazy. You can't take 7 hours. It's longer. It's not right. But I felt like adding. Does anybody else feel like adding? Because whenever people combine things, isn't that an adding kind of thing we do? It is. And if you're feeling that, that's a right feeling. And it just needs one small tweak. You don't add the 2 and the 5. What you add is a half and a fifth. Why? Well, if it takes whoever, that first person, Sue, it is a woman, not a, keep saying he. If it takes her, Sue, 2 hours to do the job alone, then how much of the job does Sue get done in the first hour? In 1 hour, what portion does Sue get done? If it takes her 2 hours to do the entire job, how much does she get done in an hour? Well, yeah, half the job. And who's the other person? We got a name, Tom. Tom. And the other person. It takes Tom alone, because he's new, 5 hours alone to do the whole job. So how much, after 1 hour, we watched Tom work, and after 1 hour we said, stop, Tom, that's all you get. 1 hour. What portion of the job would he have completed? 1/5. You see, if we turn those into fractions, we turn them into portions of the job. You ever thought about that? You ever realized if you take, you sure, Kara, think a little bit more. Maybe you have thought about that. If you take a time and you flip it, it becomes a portion of the job, right? If it takes you 7 hours to do something, mow the lawn, 7 hours to mow the lawn, then that means every hour you get 1/7 of it done. If you take a time to do anything and you flip it, it turns into the portion of the job. You never stayed up late at night thinking, yeah, if you flip times, it's portions. No, that's what weird math teachers do, huh? All right, well, anyway, that's true, and that'll help us solve this problem. Basically, you just got to flip those fractions, and then, so after 1 hour, Sue gets a half the job done. And after 1 hour, Tom gets a fifth of the job done. So if I added those up, what would I find? How much they get done in an hour. What portion of the job's all done after 1 hour, wouldn't I? If I added a half and a fifth, I would find out how much it, right? Because Sue got a half of it. After 1 hour, Sue got half the job done. Tom got a fifth of the job done. Add that up, you got whatever, a little more than a half of the job would be done after 1 hour. Right? Okay, now, okay, that's all well and good and everything. How long does it take them to do the whole job together? Well, that's what they're asking. We don't know. They call that X. Hours together to do the whole job, right? I don't know what that is. But I know that's a time, hours. And what did we just realize? That if you flip a time, it becomes a portion. So if it takes them X hours to do the whole job, then 1/X is the portion done together in 1 hour, isn't it? Same way, 2 hours, therefore a half is the portion done in 1 hour. 5 hours, a fifth is the portion done in 1 hour. X hours, 1/X is the portion done in 1 hour, together. With me? Same logic. So X, I don't know what it is. Let it be hours together. 1/X is the portion done together in an hour. Therefore, the portion Sue does in an hour plus the portion Tom does in an hour must be 1/X, the portion together in an hour. There's our equation. Now, I'm not going to do all this song and dance in the future. We'll just write it out. But I wanted to show you one time, once and for all, and it's once and for all, what it is. So here it is. So from now on, I'll just say, hey, here's the formula, follow the formula. It's 1/A plus 1/B is 1 together. That's what we'll always use for working together problems. But I want you to see that it's logical. It makes sense. It's portions of the job done adding up to be the portion done together. So we'll just go a half plus a fifth is 1/X, and then we just need to solve that equation for X. So in all the rest of them, we won't do the whole song and dance. We'll just take the 2 times and go 1/A plus 1/B is 1/X, and we'll just solve it. All right, so how do we solve that equation? You guys are pros at this, right? That was last night's homework. That's the quiz we just did. Common denominator, equal sign. What's the common denominator there? 10x. Don't forget the x. Yeah, 10 and 2, 5x. 2 times 5, 10x. 10x. What do we do with the LCD? Which is 10x. Top, 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 right? 10x, 10x, 10x. Right? You guys are good at this. Just top, top, top. Can you do the next step? Go ahead and cross cancel. Multiply whatever's left over.
So if I'm doing it like this, and I can't do 1/2 and 1/5, okay,
Is that 1.2? Or is it just
No,
12?
it's 12.
Yeah, 12, 13. I would just multiply, the LC is going to be whatever, 12 times 13?
Yeah. Oh, I was just gonna ask that. Do I do 1 over 12 and 1 over 13?
No, just 12, 13x. I'll show. I'll do one like that in a minute. All right, so we good? So let's cross cancel stuff. So 2 goes into 10 5 times. And the x is still there also. Good so far? And 5 goes into 10 2 times. 2x is there. And x cancels x. How we doing? Is that well and good? No more fractions, right? We get rid of them with the LCD. Top like that. That okay? And then 7x is 10. Like that. That good? And last step, divide by 7. There it is. There's our answer, 10 sevenths. I think it'll take it that way. Just type it in as 10 sevenths. You can make it as a mixed number. Do you guys know that's the same as 1 and 3 sevenths? Either one's good. Well, I think Math Excel wants it this way, 10 sevenths. But the test, I think, shows mixed numbers. Silently. Anyway, you okay? You guys know it's. But remember how to do a mixed number? You multiply and add. Goes back. Do you remember that? Mixed numbers. 1 times 7 is 7. Add 3. 10 7. Same thing. Those answers are the same. On that. And that answer seems reasonable, doesn't it? It's less than 2 hours. Remember how we said the real answer had to be faster than the fastest person alone? Well, no. Is that good on that? Is that okay? Questions I can answer? So these working together, there's the formula you're going to want to put on your 3x5 card for exam number 3. The 1 over A plus 1 over B is 1 over together. And anytime you get a working together, it'll be easy to recognize them because they'll literally say how long together for whatever. You'll recognize them. Questions I can answer before we move on? We good? So swimming pool, you don't even have to read all these words. Just, 17 hours, 23 hours. How long, for the pipe and the hose together. That's basically saying together, the pipe and the hose. So, same thing. 1 over A plus 1 over B, 1 over together. The A and the B are 17 and 23. Doesn't matter what order. Oh, in fact, actually, let me help you. Even though I know you know what to do. Let me show you one thing to make it even easier. So I think y'all knew that was the first step, right? Right in 1723. Now, when it comes to the common denominator, I would not actually multiply those together. What I mean to say is you don't have to. Let me show you a way to make it easy. I would literally just write 17 times 23 times x. 17 times 23 times x. 17 times 23 times x. Without any knowledge right now, whatever 17 times 23 is. Why? Because it's going to cancel out right away. You see what I mean? And I'm just going to have the 23x. Am I going too quick? Slow down for a minute there. Is everybody okay so far? So, because we always multiply through by the common denominator, right? And the common denominator is everything. So what I'm saying is just multiply through top by 1723x. And you could literally just write it just like that. You don't even need to figure out what 17 times 23 is. Actually, we will in a second. But for now, you don't need to. And then we cancel. Remember, cross cancel whatever you can. So what do we have left? 23x. The 23's cancel here. 17x. X's cancel here. Now I do need to know, what 17 times 23 is. Somebody got that? 391. Thank you. And it was okay if you wrote 391 and all those. That would have worked. You just would have had to divide in your calculator each time. I'm just trying to save you a little bit of work. But it would work either way. Good to there, and then we add them up. What is that? Is that 50? 40? 40. 40x is 391. Divide by the 40. There's our answer. We don't need to. I believe they'll take it that way. 391 over 40. So Renee, that's what I was going to show you on the one you were showing. Make sense?
Yeah. And
We all good?
It like that too.
It does. Oh, thank you. Thank you. So I'll take it just like that. Questions I can answer? So what they're going to start doing now is they're going to make them a little more challenging. They're going to, instead of just, number X, it's the same formula, 1 over A, 1 over B, 1 over together. But they're going to, on these next couple now, because if you had Math 201, we did these same ones, and that's all they ever did. They never got more fancy. Math 103, they always push it a little further now. We're in intermediate algebra now. They're going to push us, and what they're going to do, instead of just giving me number X, they're going to say, hey, John takes twice as long as Mark. Twice. What do I do with that? 2x and x. Yeah, I'm going to start sticking x's in those spots. Yeah, so here we go. Let's look at it real quick. Couldn't hurt us. So try that one. 1.5, 7.5, x. Just make sure you're okay with all the decimals. Use your calculator. My notes tell me we have another exam next week?
Yeah.
That seems kind of crazy.
Yeah, no, we should push it back. I agree.
And it says we'll finish everything by Wednesday.
Well, that would mean we would have to have a practice test on Wednesday.
Monday. Monday's practice exam and the real exam's Wednesday. Wow, okay. I'm surprised. I was thinking we had a couple weeks for sure.
Yeah, see, if you're unsure, we should be unsure.
Oh, but this is the master now. It's ours. We really can't deviate much because we have a lot of other stuff we have to do. We'll get in trouble. Yeah, parabolas and all kinds of things. All right, so we good? These coming out okay for you? 1 over 1.5, 1 over 7.5, 1 over x. And then you just multiply through by the LCD, top, which is everything, huh? So 1.5, 7.5x, 1.5, 7.5x, 1.5, 7.5x. Good to there. And then we just cancel whatever we can. So 1.5 cancels 1.5. 7.5x, 7.5, 7.5, 1.5x. X cancels x. What's 1.5 times 7.5? Thank you. Is that okay? Everybody see how I'm getting to that? And add those up. Is that 9?
9.
Yeah, 9x. And then divide by the 9. Is that like some ugly decimal or? 1.25? Just stops right there, clean. Okay. Great. There we go. This one was pretty typical, as long as you have a calculator to handle those decimals. Good on that one? All right. I'll move onward if you're good. Am I rushing you? We good? Person A can paint the neighbor's house 4 times as fast as person B. Stop right there for a second. Whenever they say in any word problem, something's 4 times something. In any word problem, not just this kind, but any kind, that's always 4x, huh? Does that make sense? So yeah, before we go for this whole section's word problems, if they say, on any word problem, if they say, 5 more, that's x add 5, because more is add, huh? 5 bigger, 5 further. Any of those kind of words. If they say 3 shorter or 3 less, then that's x minus 3. That's a less there. Right? You with me on that? Any of the bigger, larger, further words is add. Any of the shorter, less kind of words is subtract. And any times is times. So the 3 times or something like that would be 3 times x. Instead of x add 3 or something, right? We good with those words. That's pretty much any word problem, not just on these kind, but any word problem we do. When they say those phrases, more, bigger, we add, x plus 5. Shorter, less, we subtract. Times is times, 3 times x, instead of adding or subtracting. Good? So on this one, they're saying 4 times, so we're thinking, okay, 4x. And that's right. Excuse me. And then, excuse me again. Okay, so 4 times is 4x. And then not only is there that x phrase, like, x plus 5 or x minus 3 or 3 times x, in our case, 4x, but there's also always and plain x, huh? There's always one of the pieces in the puzzle, one of the items is always plain x. Whenever you have an x formula, you also have a plain x. And you can count on that, like every word problem, pretty much, that mentions one of these kind of phrases will do that. You got your x plus 5 or your x minus 3 or your 3x, and then a plain x. Very predictable. Okay, so what does that mean then? Well, that means my, 1 over a, 1 over b, 1 over together thing. One of them is going to be 4x, and it doesn't. A and B, you can switch the order. It doesn't matter which is which. Just make one of them 4x and one of them plain x. It doesn't matter at all. You can make the first one x and the second one 4x or vice versa. Doesn't matter at all. And then now the together. Normally that was always just the x, but in this problem they're actually telling us to the together, aren't they? See right there. It took them 10 days. Them, that's together.
Wow.
Right?
That's a long time to paint a house.
What are they doing? They're painting a house? Yeah. So that's our 10. They actually gave us the together this time. It's not an x, it's just straight 10. So there's our equation. Does that make sense how we came up with that?
So the common denominator would be 4x?
So, we ready for common denominator thinking now?
Times
Let me erase all this.
4x.
Yeah, so what would you do for the common? Yeah, I would just multiply them all together. 4, and remember, you only need one of the x's, huh? You don't need both. We always just one of everything. So what's the common number going to be? 4 times x times 10, 40x. Yeah. Put it down here. Now, technically, some of you guys who are real sharp are probably thinking, Mr. Heron, doesn't 4 and 10 go into 20? Wouldn't 20 be it? You're right. Technically, 20 is the lowest common number, but you could use 40. I'm just going to use 40. It'll work fine. It'll work either way. So I'll just do the 40. So 40x, 40x. Like if you put the 4 and the 10 in a box, you'd get 20. 20 is technically the lowest, but 40x will work fine. I'm just going to do 40x. It's probably easier that way. It's quicker. So go ahead. Take it from there. Multiply through. Cross cancel whatever you can. Cross cancel. So x cancels x. 4 goes into 40 10 times. So we just have 10. So far, so good. Let's get that first one. So cross cancel in the middle. Cross cancel at the end. You're all done. Solve for x. And so x cancels x. 1 times 40 is 40. And 10 goes into 40 4 times. And what does that leave? 4 and x. We good? So that's just 50 equals 4x. Last step to solve for x. Divide by that 4. So 25 have to 12.5. X is 12.5. We got it. Type in the 12.5. No, we got to be a little careful, huh? There's 2 people. There's 2 people. We got 12.5. Well, how do you do the 2 people? Yeah, where are the 2 people? Here and here. Remember, that's the A and the B. Remember in the setup, 1 over A, 1 over B. The together is the right side. Remember that? Right, so the A and the B, the 2 people are here and here, aren't they? So they're X and they're 4X. So one of them's X. X alone is one of the people, 12.5 whatever days. And then 4X is the other person. 4X, so that's 4 times 12.5. Is that 50? That's 50, huh? That's 50.
But now it wants mixed numbers, and it doesn't want it. It doesn't want
Okay. How do we know which one's which one? Well,
X is person B.
yeah, it's always by the words. Person A is the 4 times. Right? How are we doing? Am I losing you right now? Because there's a twist about to happen. Are you with me? We're about to turn a fast corner. Are you paying attention to the road? Here we go. Here we go. I had a car accident about a month ago. 2 months ago. 2 months ago. Coming home from Disneyland. Perfect time to have a car accident. All the kids are in the car. They thought it was hilarious. Because I'm always harassing them, especially my daughters, because they've had a few accidents and run up my insurance crazy. They're in their first couple years of driving. And so, and my wife had a couple things a couple of years ago, and she's actually a very good driver. But anyway, so I'm always giving them all a hard time. Like, I don't know why you guys keep crashing the cars. You're killing me financially here. And then we're on the way home from Disneyland, and I took my eyes off the road for just I blame my wife, really. I was driving, and she reached over and to get a CD out of the little overhang thing, and she's like, "I'm not in your way, am I?" And I said, no, honey, I'm fine. And I looked down, and I hit the brakes right then. Somebody had stopped. This lady had stopped for some reason right in the middle of a 50-mile-an-hour road. It was virtually, it's one of those. Anyway, you need to be. It's my fault though. I need to be watching. But she wanted her dog. She had her little dog with her, and she thought her little dog might need some water. So she was stopping in the middle of a 50-mile-an-hour road. Anyway, to stop by the side of the road to give a little water to her dog. So anyway, my wife's reaching over. I'm not blocking you. I'm like, no, honey, no, I'm going to go. And then I looked down. And anyway, don't take your eyes off the road for a second. I hit the brakes, and we skidded, and we still impacted. Everybody's fine. My kids took all pictures right away and sent all their friends. Look what Dad did. Oh, this is great. Dad crashed the car. They enjoyed it immensely. So anyway, why am I talking about? Oh, okay. So either we're about to hit a corner here. Something's going to happen. A trick. They have a trick up their sleeve on this one. Watch. So they're asking for the 2 people, right? The A and the B. The A and the B are like here and here. Okay? So it's the X and the 4X. That's all normal and true and good, which is the 12.5 and the 50, because I just plugged in the 4X into the 12.5 there, right? So the 50 and the 12.5. Okay? Now, how do you know which one's which one? Well, here's the trick. Look, it says person A is the 4 times. So you would think, okay, person A is this one. This is the 4 times. Person A is the 50. Careful. 4 times is what? Fast. 4 times is fast.
So divide.
The faster one. Who? You tell me. Somebody takes 12.5 days. The other person takes 50 days. Who's faster?
Oh, yeah.
The 12.5 days. See, if you're 4 times faster, your time is 4 times lower. The A is the 12.5. See that trickery they're doing there? The A is the 12.5. The other's 50. Those are the 2 answers, 12.5 and 50. But the A is the faster, so they're the lower time. Watch out. Little trick there. Because you see the 4 times and you think, oh, 4 times. But 4 times is fast. That okay? We good? That's the answer. We're done. That's the only wrinkle in the road I wanted you to see there. 12.5 and 50. Questions on that one? We all good? No questions? All right, so watch out for that little trickery that they pull sometimes. All right, Jake can cut and split a cord of firewood in 9 fewer hours than Dwight can. 9 fewer. Right there, what do you do? 9 fewer. Yeah, that's like saying 9 less, isn't it? And what do you do with that? X minus 9, right? So one of those pieces is going to be X minus 9, and another piece is going to be plain X, huh? Yeah, you just know that right away. There's your A and your B. You already got it. Very predictable, these word problems. at the accident scene, it was a very funny scene because the lady was funny, and she asked the officers when they showed up if the car accident can scramble little dog's brains. She actually asked the officers that.
Was the dog in the car?
Dog was in the car, in a little cage in the car.
Like on the side of the road?
No, in her car in a cage, but she thought he needed some water, so she stopped. But yeah, she said, "Officer, do you think that accident could scramble the little dog's brains?" I said, "I don't think so, ma'am. I don't think so."
Was it her fault or your fault? Well, obviously you did something behind.
Yeah, it's pretty much, yeah, pretty much. There's no question. Okay, so we good? So 1 over A, 1 over B. And what's the together? That's the 6. They're just handing us that, huh? And if you put the x minus 9 first, that's okay. Remember, the order on the first two doesn't matter at all. As long as you have the together there, the 6. All right, and then when you multiply through by the LCD, you just multiply by everything, right? 6 and x minus 9. 6 and x minus 9. 6 and x minus 9. Does that make sense? Just one of everything, huh? 6x, x minus 9, all the way through. So then cross cancel and multiply whatever's left over. And I think you'll get an x. You will get an x squared equation. As soon as x squared rears its ugly head, what do?
Get a 0.
Get a 0. Good job. Remember, first step, get a 0, and then factor and that whole thing. You're going to see x squared in the next step, right? As soon as x squared pops up, you just get a 0 on the opposite side from x squared. So bring everything over to x squared and get a 0. Remember that? Kara remembers. One of her favorite things. And then factor. X is cancel. X minus 9 is 6x. 6 is canceled, and that x distributes. X squared minus 9x. Like that, like good, and then distribute here. 6x minus 54. That's 12x minus 54. Is that good? Like that. And then at this point, so when we see this x squared, we think just jump everything over to his side, getting a 0 on that side. Whenever you see x squared, you always get a 0 on the opposite side from x squared. So what I mean is we're going to take this 12x and jump it over here. Take this minus 54 and jump it. Remember, when things jump to the other side, the sign switches, right? And that'll leave nothing over here, so it's the 0. So that'll become x squared, what's that, minus 21x? Minus 54? One x out of the first one. Yes. Good question, Car. Yeah. Right here, you mean? Just that one, right. And the other x minus 9 is still there. You're right. Yeah, and in the middle, I just do the x minus 9, and the regular x is still there. Yeah, it's just one at a time, right? Yeah. Is that good? Other questions I can answer? So here, at this point, we need to factor, huh? 0, x squared, minus 2. It does. You can't do the, yeah, you have to take the solo. Here it's the solo x, and here it's got to be the x minus 9 package. Remember, because plus or minus is package things, and they're inseparable. Indivisible, I guess, is the word. Yeah.
How come you use both of the x's, like 6x and the x minus 9? How come you didn't use just one x?
Yeah, good question. Really good question. It's because of the package thing again. Yeah, because Ajani's question is really good. Let me say it for all to hear. If this had been in the middle, if that had been like a 9 times x instead of an x minus 9, then I would look at that. Excuse me. That x is a separate x. Remember the Costco thing really comes up a lot. The plus and minus. Remind you what I'm talking about. Plus and minuses glue things together like shopping at Costco, right? Package deals. So pluses and minuses glue things together, make them a package deal, which means you can't look at them as alone and independent. They function as a package only. So what I'm saying is, Ajani's question is really good. If this had been a 9 times x instead, it's not. It's x minus 9, and they're glued. But if it had been 9 times x, then that x would be like Save Mart. You can buy just the x. It's just the x alone, and I wouldn't need 2 of them. I would say, look, I got an x alone here. Don't need the other one. And I'll just take the 9, the 6, the x alone. That's all. I wouldn't need both x's because they're both just x's alone. They're the same thing. And we don't repeat, right? We just do one of everything. But because it's actually a package deal, x minus 9, it's all stuck together. It's different than an alone x, and you got to take them both. That's a good question. Everybody dialing in with that? A plus and minus stuff. So I was just teaching pre-calculus an hour ago, and they were having issues with the plus minus and when to cancel and when not to cancel. It's a really important issue. It comes up and up and up as you go in math. Plus and minuses glue things together. Okay, so it'd be good to hear then. Does that all make sense? Cancel things and all that. And again, whenever you see x squared, you want to just know, really well. Like I said, somebody wakes you up in the middle of the night, x squared, when they get a 0. So I want to know that right away. We see x squared, get a 0. So when I see this x squared, I think, all right, jump all this stuff here to get a 0. Up to here. Now that I'm hoping that factors. Something multiplied. You can use your calculator. What times what? 6 and 9. What is it? 3 and 18. Thank you. Yeah, so how you find that, Abraham found it because he's like a human calculator, right? Just divide by numbers. 54 divided by 2, 27. And then you think, can 2 and 27 make 21 in the middle? No. Divide by 3, get 18. 3 and 18, yeah, that's the pair. Remember, you can just take the number and start dividing by things like that, and you'll eventually find it. All right? 3 and 18, like that. Abraham, you are a human calculator, right? You just knew it off the top of your head?
Oh, no, I actually just went through it.
All right. Good. All right. You guys know who the fastest human calculator in the world is? Yeah, I mean, it is me, but I hate to brag. No, it's not. No, there is a person. Have you seen him on TV?
Was he on Channel 30 or ABC when he was on that show?
I have no idea. I saw him in person years ago. Like 15 years ago. Is that true? 13. Probably 13 years ago. I saw him. The funny thing for me, he's the fastest in the world. Fastest human calculator in the world. I went to a big math teachers event. Sounds exciting, huh? Big math teachers event. And it was in Monterey, which is fun in December. It was a big, beautiful hotel in Monterey. Anyway, 300 of us math teachers went there, some big conference. And they advertised the fastest human calculator in the world. The Guinness Book World Record holder, fastest human calculator in the world, will be at this event, be the keynote speaker. But there's no picture. There was nothing, So what was so funny to me as I look back, as my stereotypes totally took over, I just thought, what's that person going to look like? The fastest human calculator in the world. This isn't just the United States. In the world. And I remember, here's what I expect. I don't know if your stereotypes are like my stereotypes. But I expected that when those curtains opened on that big stage in Monterey, that out would come maybe a 14, 15-year-old, really thin, Asian or Indian boy or girl that would come out and go, hello, I'm the fastest human calculator in the world. That's just what I thought. That's just what I pictured. And instead, those curtains opened, and out popped like a 33-year-old white guy that could just be your neighbor. Totally sweats, casual. Hey, guys. I remember thinking, what, you? And he is. He's just a regular, now he's he's like 50 now. It was a 50-year-old white guy that you saw in that show? He's probably in his 50s now. Yeah. And he's just he's American. He's just a regular guy.
How did this happen?
Did he do problems for you?
Oh, yeah.
Did he add like the other way where you add the first numbers first and then
Oh, he didn't show any tricks. He just showed what he could do. Somebody had a TI calculator on the big giant screen there, and he raced the calculator. He's as fast as the calculator. It's amazing. He had us room of math teachers, pick a 3-digit number, then someone else pick another one, and then he would add them in his head. Like 517 plus 396. Now maybe I could do it. Maybe you could do it if we had a long time to think it out. He would just go boom, which okay, that's pretty good, but not just boom. He'd add it once, and then he'd add another 396 and another 390 and another, and he would go faster and faster and faster. As fast as he could speak the words, he'd go da 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 da, and the TI calculator guy's hitting the button, and the TI calculator's doing it, and he's going da 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 da, as fast as he could say it. He could just rip them off. It was incredible. And he said, I just get in the zone. He said, I just discovered it in 3rd or 4th grade that my mind could just do this. It was like miraculous to watch.
also
He didn't have a college education even.
He can see patterns.
Yeah, he says that when I try to say the wrong digit, he said I can't. My mind must be nice, huh? I can say the wrong digit.
Right.
That his mind blocks it, and he just funnels it.
My son's kind of like that. He's constantly counting, and he doesn't even realize he's doing it. And he's
Just-
going through problems like that.
Minds are different, huh? This guy had it from a young age.
In 3rd grade, first grade, he was seeing over 3rd grade patterns in the math.
Yeah, math is patterns. That is math. Anyway, it's just interesting to me.
I have to point
Renee,
out something about
okay,
this.
point something out. What happened?
Okay, the answer is 9 and 18. It's not 3 and 18.
Okay, we'll get there. I got to quit telling stories. We got to get this done. Yeah. So, okay, good. So far, so good, right? Both minus makes minus 21 in the middle. 2 negatives multiplied by positive 54. So far, so good? Okay, so then, yeah, Renee's question is a really good one. It looks like the answer is going to be positive. Remember, because you set them equal to 0. Then, okay, I just skipped to opposite sign. Remember that works? You want me to show that? Remember, you said each one equal to 0. Remember, if two things times to be 0, if 2 things multiply to be 0, either one could be 0. So you say, okay, that means the first one is 0, or the second one is 0, and then you just jump it over, right? So it's positive 3 and positive 18, x is. Now, yeah, like Renee's saying, why aren't the answers right away 3 and 18? Hold on. Here's the problem. Here's the issue. So it looks like, let me kind of run out of room here. It looks like the answers are positive 3, positive 18, but those are both x. So what? Why am I saying that all dramatically? Well, because of the fact, look back at our A and our B. What are my A and my B? One of them's x. The other one's x minus 9. The two answers, Dwight and Jake, aren't x and x. They're x and x minus 9, right? X and x minus 9. So what? Okay. So, in other words, it's 3, and what is 3 minus 9? Negative 6. Dwight can do it in negative 6 hours.
Wow, that's awesome.
Garbage. Remember, math isn't real. And it steps beyond reality many times, and when it does, you throw it away. Math doesn't know you can't do things in the world we live in negative time. It's just running numbers. That's all math is doing. Throw both those answers in the trash. They're wrong. Well, then so 18 is one of the answers, and the other one is x minus 9, right? X and x minus 9, which would be 9. 18 and 9 are the real answers in the real world we live in. Does that make sense? So that's a little tricky. Good point, Renee. I was just maybe skip all that. Yeah, so it's kind of weird how we're used to throwing away crazy answers, but 3 doesn't seem crazy, but when it's paired with its other x minus 9, the craziness shows up. So then you throw them both away together. They stand or fall together. They go together and they fall. 3 and minus 6 cast them away. They're wrong answers. So remember, the two answers aren't x and x. It's x and x minus 9. That's a real trick. When you first see those two x's, you think those are my two answers. But you got to remember, a and b are x and x minus 9, aren't they? So it's 3 and negative 6. No way. Or 18 and 9, yeah. Those are the two. And who's who? It's whoever's shorter, longer, whatever. What does it say? Jake is fewer than Dwight. So this must be Jake. He must be the 9, and Dwight must be the 18, right? Jake's fewer. We good with all that? So that's probably all the work problems. We're going to shift gears to another kind of word problem now, I think. You all got that down? So the answer is Jake 9 hours, Dwight the 18 on that. So it's the 9 and the 18, and we know which is which because it says Jake is 9 fewer. Jake's the fewer. We're going to go on to another type now. A pool for a garden is designed. This is okay. Length to width ratio of 2, 80 feet wide. How long must it be? Okay, we're going into a second kind of word problem now, which is ratio. This will actually be the easiest kind. This will be far easier than work. Or they're called proportion also. Proportion or ratio, same thing. Proportion is just two equal ratios. So proportion or ratio. All right, so let's just take exactly what they're saying. I don't know if you can read all that. It says, let me write the keywords here. Length to width ratio of 2. Length to width ratio of 2. So what does that mean? That means L over W. It's a fraction, right? A ratio is a fraction that's equal to 2. Is that good so far? That's what that's saying. Length to width. Length over width equals 2. The ratio equals 2. Okay. And then right here, they're telling me 80 feet wide. They're telling me the width is 80. Now width is 80. So that means I take that W and I just pop it in right there. They're handing me the W. Just giving it to me. The width is 80. So that means we have L over 80 equals 2. Good so far? So I just wrote length to width ratio equals 2. And they told me width is 80. So I put in the 80. Now can I solve that little equation for L? Do you know when you have like two equal fractions, you can just go diagonal, cross multiply? You could put the 2 over 1 like that. When you just have two equal and just go diagonal. Or you can just multiply both sides by 80. That's okay too. It'll work same either way. Boom, boom, like that. So that'll be L times 1 is 80 times 2. Is everybody okay with that step that I just did? Just diagonal. You might, by the way, you might think of, wait a minute, sir, what about cross-canceling? Can't we go 2 into 80? That'd be a good question if that's in your mind. Times. That's when there's times in the middle. If we had times, if these two fractions were times, then that's when I cancel. 2 and 80 is 40. But if they're equal, you cross-multiply. Everybody see the difference? It's because they're equal. So 2 equal fractions cross-multiply. So what does that mean? L times 1 is just L. 2 times 80, 160. We're done. That's the length. That's the answer they wanted. So these will be easier than the work ones. Questions on that one?
So it would just be like L over W equal to X.
Equal to X? Well, they just told me it's 2. Right. They said the length to width ratio. Oh, like what formula would that be? Yeah. We're not going to do this exact same thing several times, or I'd give you a cookie cutter plan, but they're going to change it up. So, I'll show you. I'll show you something in a minute. This was a little different. All right, let's try. So, Cambridge Slim, 33 sausages in 12 minutes. That sounds painful. Sausages in 12 minutes. At a high-stakes eating contest. Assume that he continued at the same pace. How many sausages in 15? How many sausages in 15 minutes? How many sausages in 15 minutes? Okay, so 33 and 12. How many in 15? Well, a few more, huh? It's going to be a few more. How do we figure that out exactly? Basically, you just set 2 equal ratios. It's going to be, so if you want a plan, let's make a plan now. A over B is C over D. It's just going to be two equal fractions. So is everybody tracking with me? We're in a second type of word problem right now. We're in a proportion, or also called ratio, word problem. So we did the work ones, like people working together, painting or whatever, and that was 1 over A plus 1 over B is 1 over together. And now we have a second formula, a second kind of word problem, same as the last one we just did with the length and width ratio. We're going to have two equal fractions, two equal ratios called a proportion. Okay, and then you just plug this stuff in. It's really pretty straight ahead. 33 sausages in 12 minutes. So I'll put 33 sausages over 12 minutes is how many sausages in 15 minutes? X sausages in 15 minutes. Does that make sense what I did? And then we just cross multiply, use your calculator, and solve for X. It might help you, you don't have to, but it might help you to write down the units, sausages on the top, minutes on the bottom. Just that way you don't accidentally get something out of place, but you don't have to. Just to help you. I put sausages on the top and minutes on the bottom. Then we go diagonal, diagonal. It'll be 33 times 15. It's 12 times x. Are we okay with that? When you have equals, you just go diagonal, diagonal. What's 33 times 15? Thank you. 495. And then last step to get x alone there. Divide by that 12. And I don't know what 41.25. Thank you. 41.25. What is that? Minutes? Sausages? That's sausages, huh? Sausages. That's how many sausages he could eat in 15 minutes. A little bit more than 33. That looks reasonable. Is that good there? On that. So we're going to have a couple more. They're always the same. Two equal fractions. So does everybody track? Because, math is a lot about just getting the recipe, so to speak, the steps for each type of problem. So we had the working together, 1 over A plus 1 over B is 1 over together. Now we have the ratio, A over B equals C over D. Cross multiply. So coffee beans, I'm going to write down the key facts for you. 14 trees makes 17 pounds of coffee. Which is the amount each person in the United States drinks each year. Wow. So in America, on average, we drink 14 trees of coffee per year. How many trees are required for 474 pounds of coffee? 474 pounds of coffee. So there it is. See how it's just equal fractions? Would you be able to recognize this on the test next week? It's pretty predictable. You can tell because it's almost like a song. They just keep repeating the main theme. Like trees and pounds, trees and pounds. They just keep repeating. That's how you recognize, oh, it's just two equal fractions. It's just one of those ratios. It might help you to write what the units are, that we don't get anything out of place. I'm going to put trees on the top, pounds on the bottom. You can do it other way around. It doesn't really matter as long as you're consistent with whatever you decide to do. Be okay.
Weight, time on the bottom.
What's that?
Weight, time, distance on the bottom.
Well, it just depends on the problem. Some problems do have that. This case, it's just trees and pounds. Yeah.
The weight would be the pounds.
Yeah, you can put weight on the bottom. You can put weight on the top. It doesn't matter. It'll work either way. Just don't, violate your own system. Whatever you come up with, be consistent on that. Okay, so what do we got? 14 trees and 17 pounds of coffee. 474. So I put pounds on the bottom. I'll have to put it here. X goes there. You could have both those upside down, and that's okay, as long as it's consistent. Is that making sense? and then cross multiply, and use your calculator. Like that. Like good. And then what's 14 times 474? Oh, that's the final answer? Okay, what's this first? 6,636? Okay, thank you. And then that last step is to divide by that 17, and that's the 390 whatever? 390. What do they want? They say round to the nearest integer, 390.3, so it just round to 390. They say round to the nearest integer, so the whole that means whole number. So we'll just say about 390. What is that? 390. That's trees, huh? That's trees. So that many pounds of coffee is 390 trees of coffee. Good questions on that. All is well. So when you hear the same repeated theme, trees, pounds, like a song, repeating the main line over and over. Then you go, oh yeah, two equal fractions, just solve it that way. And the other ones, working together, they'll say working together. So that's how you recognize these two kinds of word problems. What are we doing on time? Okay, the ratio of weight of an object on Mars to Earth is 0.4 to 1. Okay. So give that a try. Then say, how much will a 7-ton rocket weigh on Mars? So see if you can do part A. Don't worry about part B. Let's just do part A for now. So the ratio of weight on Mars to Earth. So you can write M and E. You don't have to. Might be helpful. Mars to Earth. So it's 0.4 or 0.4, however you want to write that, same thing. 0.4 to 1. Good so far. Now, on the other side, I'm going to have a 7 and I'm going to have an M. Right? Because there's a 7-ton rocket. When I say, hey, something's a 7-ton rocket, that must be on Earth. Right? Because they're not specified. They're saying how much would it be on Mars? So it'll be different on Mars. 7-ton must be what it is on Earth. You with me? When somebody says the line, how much will a 7-ton rocket weigh on Mars? They mean it's 7 tons here. What will it be on Mars? Right? So the 7 tons is the Earth weight. It's the E.
Asking the questions, how much does a ton of feathers weigh?
Right. That's the one I like to ask. Yeah. We good to there? Does that make sense? That the 7 is actually the Earth weight, and you don't need to write tons or just 7, and we'll get our answer in the end, and it'll be in tons. Mars is what we're looking for, right? That's what they're asking. How much will be on Mars? So there it is. And so diagonal, zip, zip, and so that's 0.4 times 7 is 1 times m, and is that 2.8? 2.8 tons on Mars. No way less. 2.8 tons on Mars. And part B would be the same thing. I'm gonna move on if that's okay. There's other things we need to look at. Is that okay? Questions? Is a kind I'm sure you've done before. There's the third kind. There's 3 kinds of word problems in this section. And this is just my first of 3 sections, but it's the biggest. So the last kind is travel. You've done travel. Have we done travel in here?
Yeah. Dirt.
Yeah, we did. Okay, I forget. Yes, so we've done. So this is our second look at dirt. It's going to be dirt again. Same kind of thing. Distances, rate times time. They're just going to try to add a little bit more trickery to it. And that is that they're going to have a current, a stream. Water's going to be moving in these problems. So they're going to try to add a little bit of movement to it. So I think you know what that means. Or what if you're in a boat? What if you can paddle a boat your boat speed. You can paddle your boat at 10 miles an hour. And what if the river, the current in the river, let's just call it current. What if the current is moving, 3 miles an hour? So how fast will you be able to go? If you can paddle the boat like on a still lake where there's no water moving, if your ability to paddle the boat is 10 miles an hour, let's say, as fast as you can go, 10 miles an hour, and then you get on a river that's flowing, that's the best river I can draw right there, that's flowing downstream at 3 miles an hour, and you're paddling downstream, how fast will you be able to go? 13. You just add them up, huh? But what if you turn around and try to go upstream? You're going against the current, so what would you do with the 10 and the 3 in that case? You would subtract them. If this is with the current, downhill, downstream with the current. This is upstream, uphill against the current. Yeah, so I think you all sense that you would just add them if you're going with the current and subtract them if you're against. That's right. Right? Just however fast you can go, plus the current helping you when you're going downstream with the current. And however fast you can go, 10, minus if you're trying to fight against the current, right? You're trying to paddle up 10 miles an hour and the current is going against you at 3. It's going to subtract. It's going to slow you down. That's how fast you would go, right? And fast, what's the word we use? Which word means how fast? Distance, rate, or time? What's the fast word? Rate. Huh? So this is rate. So in other words, boat plus the current and boat minus the current is what we need to put in the 2 rate boxes. So the rate's just a little more complex in these. The rest of the problem is the same. So with the current, we have the adding, and against the current, upstream, the other one was downstream, we have the minus. That's the only difference. The rest of the problem will be the same as the other travel ones were. The only difference on some of these travel ones is when you have like a river moving or a plane in the wind, with the wind, against the wind, same kind of thing. You have the boat plus the current when you're going downhill with it, boat minus the current when you're going uphill against it, negative. And those go in the middle 2 boxes because those are rates. That's how fast you go. The rest is the same. Bless you. What do I mean the rest is the same? Well, what do we do? Well, remember on these we always need 4 boxes. Let me write that. 4 boxes. 4 boxes from the words. So we need 2 more boxes. What else can we get? 5 miles upstream. 5 miles. Is that a distance, rate, or time? That's a distance. Upstream. So it goes in this box, huh? It's the uphill box. 11 miles downstream. That's the distance down. Good so far? Questions so far? Everybody tracking with me? So far the only difference is when you're in the river, boat plus current, boat minus current for your 2 rates. Got my 11.5. What else do they give me in this one? Oh, I missed the 3 back here in the beginning. I kind of wrote over it. There, the stream, the speed of the stream is 3 miles an hour. What do I do with that? Stream. That's the current. Yeah, good. That's how fast the current's moving. The C is 3. And that's good because we didn't want 2 letters. The C is 3. And they'll always give you either one or the other. They'll either give you the B, the boat speed, or the C, the current speed. They always give you one or the other. So they're telling me the current speed is 3. So those middle boxes now become B plus 3 and B minus 3. Okay, so I've got 4 boxes from the words. Got them. Remember how you always find the other 2 boxes? It's from the equation. But the difference now is we have the last 2 boxes. The last 2 boxes, they come from D over R equals T. D over R equals T. Where am I coming up with that? It's because, look at this equation right here. Distance. First off, I need the t box. Everybody see I need this and I need this, which are boxes under the letter t, aren't they? I need time boxes, right? So I'm trying to find t. What is t? Well, if you take the equation d equals r times t, that is our equation, and you want t, I need t. How do you solve that equation for t? You divide by r. So what does t equal? D over r. That's where I'm coming up with that. So these boxes on the right, the t boxes, are the d box over the r box. Everybody following me? The difference between now and what we did, whatever it was, 3 weeks ago, a month ago, when we did these kind of problems, is we always had the blanks on the left. On those problems, we always had the blanks on the left, and that just came by multiplying, because d is r times t. So when the blanks were on the left a month ago, we always said, oh, we'll get these, we'll just multiply this box times this box, and that'll go there, and then this box times this box, and that'll go there. That was great when you have the blanks on the left, because d is just equal to the r box times the t box. Great. But now my blanks are on the right. That's what will be new on this section. It'll always be that case in this section. Your blanks will be on the right. So if they're on the right, you need t. And if you solve the dirt equation for t, that ends up being d over r. So that means d box over r box. So this is going to be, go in here and whoops, write it. It's going to be 11 over b plus 3 and 5 over b minus 3. Does everybody see that? See how I got this and I got that? Left over middle, left over middle. That's what this equation says. T alone is left d over middle r. So that's how you get the blanks on the right. It's left over middle, left over middle. Okay, now with all that done, are we almost there? We are almost there. Now let's grab out those last two boxes. 11 over b plus 3 and 5 over b minus, it's supposed to be 3, huh? 11 over b plus 3 and 5 over b minus 3. And are they equal? Can we set them equal? Yeah, absolutely. Why? What in the problem says that they're equal? Yes, there it is. You can hardly read it. It's all written over. Right there it says same time. And those are time boxes, so they are same. They are equal. Same means equal, as you know. So there's our equation. Now we just cross multiply, solve for b. Is that okay? A lot of steps there, huh? So let's do that. So we're going to go zoom here. So we got 11 b minus 3, 5b plus 3. Like that. Boom, boom. 11b minus 33. Boom, boom. 5b plus 15. And then, guys, got to solve for b now. That'll be the boat speed. How do we solve for b? What are we going to do? Remember when we have when the letter is on opposite sides, you just get rid of one of them. Get rid of the lower one. Right, so do that. Don't worry about the 33 and the 15 right now. First do something about the two b's. Get rid of the lower one. So subtract 5b. Boom, like that. We're going to get 6b minus 33 is 15. And then add the 33 to both sides. It's gone. And 6b is, what's that, 48. Last step to get the b alone, divide by 6. So b is 8. It's 48 divided by 6. So the boat speed is 8. That's probably all they want. Yeah, speed is 8 miles an hour. Why do they say, look, it says, find the speed of the boat in still water. Why are they saying still water? But why don't they just say find the boat speed? Yeah, it means no help or hindrance from the current, right? No, just the boat alone, not the water, the current speeding it up or slowing it down. Just the boat alone, and that's what B is. B is the boat alone. That is what we found. That's the boat. That's their way of saying the boat alone. Still water. The boat, 8 miles an hour, all by itself. Is that good? Did you track with all that? It's kind of complex. Let's try one of those. So again, what's different? There's two things that are different. In the middle, when you have a current, in the middle it's boat plus current, boat minus current. And then you end up with the blanks on the right. When the blanks are on the right instead of the left like they were a month ago, it's left divided by middle to get the blanks on the right. All right, a barge. A barge moves 8 kilometers per hour in still water. It travels 55 upstream, 55 downstream, total time 16 hours. What's the speed of the current? All right. Dirt, distance equals rate times time. Set up the boxes. So what are you going to put in the middle 2 boxes right away?
8? No.
See, there's a current, right? Whenever there's a current, which speeds up or slows down a boat, right in the middle it's boat plus current and boat minus. And the plus is the downstream. That adds to the speed when you go downstream. And the minus is upstream, fighting against the current. It's minuses, it slows you down. Right, that's always the first step when there's a current. Take it from there. Yeah, that 8 is the B, huh?
Yeah.
Everybody seeing that? When they say the barge, 8 in still water, they mean the barge alone, right? No help or hindrance from the water. So the B, this time they're giving me the B is 8. So that would be 8 plus C, 8 minus C in the middle. Everybody seeing that? The barge in still water means the barge alone. Keep going.
Okay, and then it goes upstream and downstream altogether in 16 hours. Or one trip in 16 hours.
Right. First, you need these. You should need these first. Those don't come from the words. So the 55 and 55 are here, right? Because it says 55 kilometers upstream, 55 down. That's distance. Kilometers is distance, right? Okay, now, if you're worried about that 16, don't worry about it yet. We'll come to it in a minute. First, we know how to get these right 2 boxes. It has nothing to do with the 16 right now. Remember how you always get the right 2 boxes? Left over middle, left over middle. Remember, it's divide. That's one of the things that's different here. It's not multiply. It's multiply a month ago when we needed the left 2. Remember that? So it's divide when you need the right. It'll always be divide in this section of the course. It'll always be divide. Does that make sense? So it's left over middle and left over middle. Are you with me? Is everybody catching on to that difference? Because the blanks are on the right, it's divide. It's left over middle, because the blanks are on the right. A month ago, the blanks were on the left. They were over here. And that's when we multiplied, because that's what the equation says. Right? When you take dirt and you want D, well, yeah, that's just R times T. If you want the left, if the blanks are on the left, you just multiply the R and the T, the right 2 boxes. But I don't want D here. I want T. My blanks are on the right. So if you want T, you got to divide by R, don't you, to get T. T is D over R. It's the left box, left over the middle box. Everybody see that? left over middle.
Okay, so since the bottom box is opposite of the top box, do you still multiply it by negative? That's C plus 8. I mean, do we want to do that? Like we do in the other ones, 8 minus C, 8 plus C. Do you want to make it into C plus 8 and C minus 8?
No, it's okay. You can just leave it as, yeah, good question. You can just leave it as is. Now we're ready for the 16 fact. So I'm gonna take out that 55 over 8 plus C and that 55 over 8 minus C. Everybody good so far? You always take out the right two boxes. You do something with them. Now on the last problem, it said the words we love to hear, same time. Doesn't say that here. I cannot set these. These are times. This is the time. The boxes on the right are all about time. But it doesn't say same time, so I cannot set these equal. They are not equal. They are not same. Well, what do I do with them then? Well, I do what this says. Total time. Instead of same time, it says total time is 16.
So it's going to be plus equals 16.
Add them up, and it'll equal 16. Exactly. Does that make sense? The total of them is 16. So last time it said same time, set them equal. This time it says total them, and it's 16. Now we have to solve that equation. That's painful.
Yes, it is.
So what do? When you got fractions? 8 plus C, 8 minus C, top, top, top. Right? You know all about it. So 8 plus C, 8 minus C, 8 plus C, 8 minus C, 8 plus C, 8 minus C. Is that good? Top, top, top. And 8 plus C's cancel. 8 minus C's cancel. So what do we have? 55. 8 minus C. 55. 8 plus C. And 16. 8 plus C. 8 minus C. We good to there? Now we got to deal with all that mess. So, is that 440?
Yeah.
Thank you. 440 minus 55C, 440 plus. So now, the right side is a big pain. Remember how we do it when we got like a number, then a couple parentheses? You do the parentheses first, right? Just leave the 16 sitting there. Can I skip a step here? If you FOIL out those parentheses, can you tell what it's going to be?
64
minus C squared, because the middle stuff will drop out. It'll be 64 plus 8C minus 8C minus C squared, and these two will drop out. Is that okay if I just kind of skip that? Right, if you FOIL this, can you read all that? I kind of scribbled it. It'll be 64 plus 8C minus 8C minus C squared, and these guys will drop out. So it's just 64 minus C squared.
And then 16 times that.
And then 16 distributes through this. And over here, 440 and 440 make 880. These guys drop out. 16 distributes through. 1024 minus 16C squared, I think.
Mm-hmm.
Good? We're going too quick? Is everybody seeing what's happening? So now we have to solve for C. Oh, yeah, let me give it a tip. Okay, you know that big thing I said, whenever you see x squared with an equals, you always want to what? Get a 0. Well, don't pay any attention. Now I'm changing my mind. Well, no, that's true in general, but there's sometimes you can do something a little easier, and this is one of those times. So what I really should have said is if you, I just try not to give too many details all at once, but if you have x squared and x to the first, yeah, you got to get a 0 and that whole business. But if you just have x squared and numbers, see how we just have c squared and number? We don't have c to the first anywhere.
Just square it.
Yeah, that's easier. Just get x squared alone, or c squared or whatever, and then root. It's quicker. It's easier. You don't have to do the whole 0 factoring routines. Everybody see that? So for x squared equations, there's 2 different ways we go. And then this is factor. So I'll give you more the rest of the story here. If you have x squared and regular x. That's what we had in the last one, didn't we?
Can you
No.
do that when you have a
Where was it?
negative coefficient for the x squared?
Yeah, we can.
Oh, okay.
I'll show it. Yeah, like back here. See back in this one a few minutes ago? We had x squared and regular x, huh? So yeah, I had to get the 0, I had to factor and all that business, right? When you have x squared and regular x, you got to do the hard way. You got to get 0 and factor and everything. But on this one, I just have c squared and then look, just numbers. I don't have regular c, just c squared and numbers. So this is easier. When you just have x squared and numbers, just get that thing alone and root it. You don't have to mess around. So I'm just going to subtract 1,024 from both sides. So we have a calculator. What is that?
144 negative.
Thank you. Bring down the minus 16t squared, c squared. Good to there so far? Get the c squared alone, right? Get x squared alone. Get the c squared alone. What do I do to get c squared alone? Divide by the negative 16. And hopefully that's something nice. I'm running out of room. I put it here. It's just 9? C squared is 9? That's beautiful. So right here, so root it, C's 3. We don't need the plus or minus because you can't be negative current. So the current's 3. Does that make sense? It's a little easy. If you just have c squared in numbers, just get it alone and root it. You don't have to do the whole factoring thing. You only have to do the factoring thing when you have x squared and regular x. So that's a tough one. Questions I can answer. We good? Doing okay? We're an hour and a half in. We got a half an hour left. We got a little more work to do. All right, there it is. Speed of a moving sidewalk in an airport is 4 feet per second. What's with the moving sidewalk? It's like a current. Do you realize it's like a current? Right? You get the idea? Like when you put a boat in the river, however fast you paddle plus the current together speeds you up, right? That's what happens on a moving sidewalk in an airport. The sidewalk is moving plus you walk. So there's your walking speed plus the sidewalk speed, just like your boat speed plus the current. Makes you move faster, right? That's all it is. It's a current problem. It's just a funny way to make a current. So I'm just going to go, all right, I got you. Distance, rate, time. Do my 6 boxes. And boat, instead of boat plus current, I'll put what? We don't have a boat. How fast we walk plus the sidewalk. I don't know what letters to use here. How fast we walk plus how fast the sidewalk's moving. Well, minus. Supposed to be 1 plus 1 minus. Actually, we're not going to do the minus. Do you ever walk against the sidewalk?
Yes.
If the sidewalk's moving.
You walk against it?
If the sidewalk's moving.
So now, in an airport, you would get on the moving sidewalk and walk. What do you just real life? What happens in an airport? You get to the airport, you get the moving sidewalk or any place they have at the malls or whatever. You get on the moving sidewalk and you walk, speeds you up. But when it's time to come back, you don't ever walk against the moving sidewalk. You just walk on the normal ground because you wouldn't want to walk against the moving sidewalk. That wouldn't move you very fast. Plus there'd be those people coming against you, right? So in other words, the trick on this one is it's not like a boat in the river. You've got no choice. You've got to go with the river and then against the river. Because you can't go on the ground, right? But with airports and moving sidewalks, you're going to go with the sidewalk, right? can walk on the moving sidewalk, and this 14 feet on a non-moving sidewalk. Do you see that? They walk one direction on the moving sidewalk and the other direction, not against it, but just normal. Non-moving, meaning normal. Just their walking speed. Everybody seeing the trick there? It's walking speed plus the sidewalk, and then just normal walking speed, because it's non-moving. So they're on the moving sidewalk, so it adds to their speed, and then they're on the non-moving sidewalk. It's just your walking speed alone is what moves you. Everybody see the trick there? So it's not boat plus current, boat minus current. It's just walking W plus S and then just W.
You're going to put the easiest one of these on the test, right?
I doubt it.
Oh, my God.
All right. So here we go. So, well, let me let you. I think you get more out of it. Let me let you take some next steps. So that was the rest is normal after that. See what you can get.
On and non.
Right. On and non. Exactly. Okay, here we go. Speed of moving sidewalk airboard is 4 feet per. That's the speed of the sidewalk. Where's that go? S. That's the sidewalk speed. Person can walk 72 feet distance on the moving sidewalk. That's distance on. Same time. Great. We'll use that in a minute. Same time. We like that. 14 feet on the non-moving. That's the distance on the non-moving, right? Good. You got 4 boxes. You know how to get the right two. Get the right two, and then pop them out and set them equal, because it's the same time. Equal times. How do we always get the right 2 boxes? How do we always get the right 2 boxes? Nobody knows? How do we get the right 2 boxes?
Left over middle.
Divide it, right? You get the right 2 boxes by dividing left over middle. Always. So it's going to be left over middle, left over middle. Is that good? Always get the right 2 boxes by left over middle, and then you grab out these 2 boxes and set them equal because it says same time. Those 2 time boxes are equal. There it is. How do we solve 2 equal fractions? Diagonal, diagonal. So this is easier. Like that. Distribute. 40, 56. How do you solve for W there? Minus 14 W. What's that? 58 W?
Wow.
56 divided by 58. There it is. They want you to reduce that, like always. Divide by 2. 28 29ths? That's the speed of the person walking, their walking speed. I don't know if that's miles per hour. Oh, it's feet per second. Yeah, the units are feet per second. So just under 1. That's just less than 1 foot per second. Is that typical? Do you walk about a foot every second? I don't know.
That's
That good? That's what they want, is walking speed. Questions? Okay. So it's a travel one. Distance is rate times time. Okay. 12 kilometers faster than a freighter. Faster than a speeding bullet. Faster than a freighter. Hey, is there anything in this problem about current?
No.
Did they ever say it's on a river and the river speed? No. So this is an old one. This is something you could have done a month ago. It knows I'm not going to go boat plus current, boat minus current, or walking speed plus sidewalk, or anything like that, because what? There's no current or moving sidewalk or the ground's not moving, the water's not moving, nothing's moving on this one, right? Or if it is, they're not telling me about it, so I don't need to worry about it. Making sense? Everybody see that? Do you see how I'm identifying that? So if the current is moving or the ground is moving with moving sidewalk, or the air is blowing and you've got a plane in the wind or with the wind against the wind, that's when you need the boat plus current, boat minus current in the middle two boxes. We don't need that here. Not here. So just more regular. So just find your 4 boxes, get the right 2 by dividing. Okay, here we go. 12 faster. Isn't that like saying 12 more?
X plus 12.
X plus 12, exactly. We good with that? See how they're saying 12 more? X plus 12. What is X plus 12?
Can you substitute it with the net just for freighter?
One of these, the 2 things we're talking about, you're right, is freighter and steamboat. And they're saying the steamboat is 12 faster. So the rate for the steam is 12 plus X or X plus 12. Either way, it really would be fine. But I know we're used to the extra, so I'll put it this way. And the other's X. Does that make sense on that? If you could switch them. It doesn't really matter. But you've got to know it's the steamboat that's the X plus 12 and the freighter that's the X. Everybody good with that? 12 faster, 12 more, X add 12. The steamboat's 150 kilometers. That's the steamboat distance. The freighter's 126. That's the freighter distance. Good? Got 4 boxes. Get the right 2 boxes by dividing. Pop them out and set them equal. Doesn't it say same time? Yeah, same time. So get the right 2 boxes by dividing. Pull them out, set them equal, because it says same time.
So, find the speed of each of them.
So this would be 126 over X, 150 over X plus 12. 26 over X. It's 150 over X plus 12. Diagonal, diagonal. Right? Set them equal because it's the same. Cross multiply. Okay, can I go dot, dot, dot? Solve it from there. Same old kind of thing as regular. I'm going to move on. If you're okay with that, questions on that? We good? All right. That's how they actually do count fish and deer on the mountain and rabbits in the field. They biologists use it's a ratio problem. So basically, I don't have time to give you the whole theory of everything, although I'd like to. I think it's interesting. But anyway, we don't got time. Tag over total. Tag over total is tag over total. This is what they actually do. They catch, tag, and release. It's called catch, tag, and release method. That's what they really do. Right? You ever thought about that? It's a difficult problem. How do you catch fish in a lake?
Go fishing.
Yeah. So they catch a bunch with a net, tag them, release them, let them mix around. Day or 2 later, catch a bunch more. Whatever percentage have tags, they let that is indicative of the percentage of the whole lake that has tags, and that way they're able to estimate the number of fish in the lake. I don't know if you caught all that. I don't got time to unwind that more. Let's just crank this out. 124 trout. They catch 124 and tag them. So that 124 end up all being tagged, right? So that'll be a tag number. Oh, and this is the first catch, and this is the second catch. First catch, second catch. So, or they call it capture. They call it the capture recapture method. Also, it has a few different names. So capture recapture. So anyway. So the first time you catch a bunch of fish, 124, you tag them, throw them back in the lake. Later, 28 are caught, 14 have tags. So that means 14 tagged out of 28. This is later. A recapture, later. Find X. So does that make sense? So we've got 124 over X is 14 over 28. Did you get the idea so far? Get the format I'm using? Tag over total is tag over total. 124 were tagged in the first catch. And then they threw them back in, caught them later. 14 were tagged out of 28 total in the recapture later. Now, I'll show you the math. We'll finish it up. But I know time is short, but I hate doing math without good reasons. To me, it's much more interesting and makes sense and can remember it better when there's a reason for it. Like, why would this work? Let me appeal to your reasonableness for a minute. 14 over 28, that's a half, huh? If I reduce, that's a half. 14 is half of 28. So that means when they recaptured later, they found, there's like a week later, a couple days later, whatever, they grabbed and they found half of the fish in the lake had tags, right? You know what that's like? That's like polling. If I went out and I asked, 28 people at random who they're going to vote for in the school election or whatever, and 14 people said they're going to vote for Mary whatever, if I found 14 out of 28 that were going to vote that way, I would think, probably half the people, right? Even though we have, 23,000 here at Fresno City, I didn't ask all 23,000 people who they were going to vote for. I only asked 28, but that's what polling does. You just asked a small group, and it was random, so you assume that's representative of the whole group, right? Well, that's what they're doing with the fish. They just grabbed 28 later and found 14 were those ones they'd already tagged previously. Some of the ones they'd already tagged previously. So they're thinking, later we just threw a net down, pulled up 28 fish, looked at them, found 14 had tags. So that's half the fish we just grabbed at random. That's like me going out and asking people at random who they're going to vote for, and half of them say they're going to vote for Mary. So you're thinking, maybe half of all the people, probably. It's just random. So probably half of all the fish in the lake have tags. Does that make sense? You get that idea? Okay, so what? Well, we know how many fish have tags. We tagged them a week ago or whatever. Exactly 124 have tags. We caught them a week ago and tagged them. And we're thinking from our sample a week later that that's about half the fish in the lake because we grabbed at random a group and looked at them and it was about half that group. So probably half the whole lake is tagged fish. So if there's 124 tagged fish and half the whole lake is tagged fish, how many fish in the lake? Whatever double that is. 248, right. About. It's random, right? Because you don't know. Just like polling has got a little bit of randomness to it, but it's generally reliable. That's exactly what they're doing. You get the idea? By just recapturing and looking, they're like polling the fish. And they're saying, about half the fish have tags. We know how many we tagged. We know about how many are in that lake. Kind of a genius little system. So that's it. That's what you're doing. That's why this works. So let's solve this thing. Now we're going to get exactly what you guys just said. We're going to get double the 124. You know how to solve this, right? How do we solve it? Diagonal, diagonal. 124 times 28 is 14 times x. What's 124 times 28? Is it 2472? 3472. Thank you. 3472. 14x. Last step to solve for x. Divide by 14. That'll be the 248. About 248 fish in the lake, as we already reasoned out. Make sense how they do that? Pretty tricky little method, huh? That's how they count everything. All critters, I mean. Not everything. That's how they count all the critters. It's like deer in the forest. They tag them, release them, grab them. Rabbits in the field, same thing. That's how biologists count critters, because it's easier that way. All right. We have